Graphing rational functions. We can graph rational functions using what we know about transformations. So let's take a look at the basic graph of f of x equals 1 over x squared. For 1 over x squared, our graph looks like this. It reminds me of a nuclear tower. It goes up, and then the other side goes down. If we wanted to graph this function, 1 over x plus 3 squared minus 5, remember what we know about transformations and how we could apply this. I know that the minus 5 out here is going to shift my graph down 5 units. I also know that the positive 3 here is going to shift my graph to the left 3 units. Remember, if it's in with the x, it shifts it side to side, and it shifts it opposite the direction that you think the sign indicates. So this would be where the graph would move to, which means instead of these little arrow little nuclear tower things being centered there, this entire graph would move down 5 units and to the left 3. So it would look more like this. Now, my graph is not very accurate. You could graph it in your calculator and you would see it would look very similar to that. When we're graphing by hand and not using transformations, there are quite a few things that can help us when we're graphing rational functions. We have to know what our domain is, and we have to find the values for all of our asymptotes. The asymptotes kind of serve as separation lines for our graph. So once we find the location of the vertical and the horizontal asymptotes, we want to sketch those onto our graph using dashes. Once we know where those asymptotes are, then we want to see if we can write the function in lowest terms. If there's any factors in the numerator and in the denominator that we could cancel out, we want to cancel those out. Remember, that's kind of unusual, but when you have that, it means your graph is going to have a hole in it. Now, based on what you've done in the first couple of steps here, you want to find several points within each section of your graph. Okay? That means within each area between your asymptotes. The easiest way to do that is to go to your table in your calculator and find values. So let's look at a couple. Here, let's look at 6x over x squared minus 25. To find my asymptotes and my domain, I need to look at where the denominator is 0. So I need to take the x squared minus 25, set it equal to 0, and solve that. Well, I know this would factor into x plus 5 times x minus 5, which means I have 2 factors. I'll set each factor equal to 0, and that will give me 2 places, 2 numbers, that make the denominator 0. These are our vertical asymptotes, but they also tell us the bad numbers for our domain. This is a rational function that we cannot simplify any. So this tells us our vertical asymptotes, and it also tells us that our domain is everything except -5 and +5. So that would be -infinity up to -5, union -5 up to +5, union +5 up to infinity. This is one of those times when interval notation is really much more complicated to write out the domain. So I want to use dashes over here for my vertical asymptote. So here's a vertical asymptote. I'm trying to do it a little bit on the side there so you can see my lines. Okay. Now I want to find my horizontal asymptotes. Remember that your horizontal asymptotes depend on the degrees of your function. If the degree in the numerator is larger than the degree in the denominator, which it is in this problem, your horizontal axis is going to be the line y = 0, which is just right on top of that x-axis. So I need to now find points in this area between my asymptotes, between my vertical asymptotes, and in this area past my vertical asymptote. So I'm going to go to my calculator. I want to type my function in, my y = screen. You see my function is 6x divided by x squared minus 25. Then I want to go to my table. Table is second graph. Now I have my table set up in an ask mode. To set the table in ask mode, you go to second window. You can use the ask mode, but I'm going to change mine back to automatic mode here. So I'm going to put it on auto and now go back to my table. Your calculator may already be in auto mode. I want to find x values that are out here. So that means I want x values that are less than -5. So I'm going to scroll in my table till I get to those. I see that -5 is an error because that is not in my domain. So here are my values that I'm going to put for these points. -6 is down a little bit past -3. And then these values are all just getting closer and closer to 0. As I keep going down, look how these are getting closer and closer to 0. So that tells me that my function is doing this. It stays below the x-axis. It's just getting close to 0. Now I want to look at numbers between the asymptotes, between an x value of -5 and +5. Okay. So for these, -4 has a y value of almost 3. Let's see, -2 has a y value of about 1/2. I don't have to graph every point. I just want to graph some of them. 0 has a y value of 0. Let me graph some of the positive ones here. 2 is down a little bit past -1/2. 4 is down almost to -3. So it looks like the middle portion of my graph is going to look something like that, where these all these tails are just getting close to my vertical asymptotes. Now I want to extend and go past the +5. So x of 6 has a y value of a little bit more than 3. X of 9 has a y value of real close to 1. And then these are just going to get flat like the other end did. So here is this portion. And your graphs are just going to be, you know, a little rough. The more points you get, the better. Oh, let me put my window on a standard window and compare it. I see each portion of the graph. Here the calculator shows the vertical asymptotes even though they aren't really part of the graph. Sometimes your calculator will display them, sometimes it won't. Your graph should actually have it done with dashes or dotted lines.